wait. Okay. So hello everyone. I hope you can hear me clearly. I'm sorry if there are noises outside. And my name is Huang Gong Hui, or you can call me Gong Hui Huang. I believe that how you see my name on paper. And today we present my data science text D1 for the course SIT112. And let's begin, huh? And the text I will be presenting today is analyzing YouTube video data from news publishers. We will be analyzing around 4 main new publishers. And the data, the YouTube video data I got was from this file like the IPNB. I crawled it using a YouTube API key. And let's get started. Scroll down to the data cleaning part right here. Read the data and create some new columns, some new date columns that we will later use for better analyzing. And yeah, I believe this is regex. It's okay, regex. And by the way, I also dropped some NA columns, some no columns. Merge the two data sets since some tags may need data from both data sets. So yeah, I merged it beforehand. And like the function for merging is pretty similar to the join table in SQL. Here just print the columns out to better visualization. Let's get started. E11. Okay, we'll start with E11 first. Alright. So the tags tell me that to compare the distributions from number of likes, view likes, comments for the videos. Okay. For maybe subplot, right? Okay. So column names. First, we will take the value that we will analyze in this text out, which are view, like, and comment, right? And in this variable, sorry. Create a plot, give it a name. Then loop through the column names, just enumerate it so we can get the I. So there's like a counter I for the I. I don't know how to explain it clearly in English, but like it will create it will assign each value right here with number, like this is O, this is 1, this is 2 for the I. Okay, so lot bar plot, name and title, the label is the column names, and the Y label is the frequency, right? Okay, then show it. This is it. Sorry I didn't change the colors, but as you can see from these 3 histograms, the trend are pretty similar, right? The shape are similar. Okay, yeah, the shape is similar. So which means the views, likes, and comments are distributed in a similar way. Most of the videos are preload in these all 3 values. When you see this line right here, this bar right here, yeah, it's really close to 0, and many of them are really close to 0. So there are not many videos with huge amount of like, view, and comment. There's some here too, but yeah, this is what we get from it. Most videos are loaded in view, like, and comments. Okay, next has E12. We saw the number of views, likes, and comments for the video published by different news publisher. So now we have another value to consider, right? So now we use group by. Change the title. Change the title is a news publishers right here, and we group it with these three values, naming it by total views, like comments. We use sum to get the total number. Alright. Okay, here what I usually do to keep track of what I did is that I print it out. I print it out every time I create something and group like group something. I create some some kind of frame. I just print it out to keep track of what I just did. Now we can just create a plot and plot it out. I don't think there are many things to talk about here. Oh, by the way, I did some data cleaning for better readability, like create this underscore, they remove this underscore and rotate it by 45 degrees, or else it will look like this. It will look like this. And I list it in from high to low, so I send it false. Yeah, and from this figures you can see that CNN just overwhelmed other news publishers, right? It's pretty consistent in all views, likes, and comments. Yes, it's a more common one. It's a more common channel for this COVID-19 topic. Alright, next. You said that the test only require like two tests for E1, but I accidentally did quite a bit. So you can review it too. But right here I will review one more. How has the number of comments changed over time? So the number of comments, right? We get over time, right? So we get a comment date, and I will like separate it by week. Separate by week. Okay. By example, the week here. Okay. And by the way, here I also convert the data from the CSV file to datetime type, because the data from the CSV file, if taken out, will be string type, so I have to convert it. So this example will work. Then print out, print out to keeping track of it, like I said. The size of it, count the number of comments each week. Then we just plot it out using line, because we are analyzing the trend over time, so we're using line plot. This is what we get. As you can see here, the number of comments just surge before 2021, right? And this period right here is where COVID-19 actually bloomed out over the world. So yeah, this makes sense. Is to continue to fluctuate until here. Yeah, this is when everything's under control. So yeah, it becomes quite stable. This text below, you can review it, but I will just read two because I don't have time for it. Okay, next. One text in the E2 section, right? Okay, I need the E27 to compare the average number of videos published per week across different news publishers. The average number of videos published per week. So first per week, right? So first I still have to convert it to datetime type. Set the index. Set the index to publish ad first. So this resample things gonna work. Group by and resample gonna work. So yeah, and reset index it a little bit. Print it out to keeping track of it. Right here, yeah. We're gonna have this little table right here. This present all of the information already. Then we group it by channel type, by different channel and the data. Okay, then plot it out. About time. Oh my god! And as you can see from here, these values are pretty close. But from here we can see that BBC News are the highest, have the highest rate of video published per week. But it's pretty like the rate compared to other trees are almost the same. Unless it's CNN. Okay, so about the challenges, I don't face much challenges around here, but if there are any, it would be the data type. No, the data frames are, though the data is pretty huge. There are so many columns in here, so it's pretty hard to like understand the data. So I have to read it. I have to visualize it a lot to read the data to better understand it. So yeah, this is it. This is it. There's not much data, like no data, and I don't really encounter that any obstacles because of no data, because I already chopped it all. But yeah, there's not much obstacles actually. The data frame is just pretty huge. The data is pretty huge, so it just takes time to understand it. Okay, by the way, this is the end. Thank you for your attention, and goodbye.